what's called the law of sines. Well, we're looking at two different things today. We're looking at finding area of any triangle, and we are looking at the law of sines. The area of the triangle thing we're just going to spend a minute on. We're not going to take too long on the area of a triangle, but the law of sines, nope, not too long. But the law of sines, that's our main focus for today. That's where we're going to look at some example problems and all that good stuff. So, before we do that, let's review a few things. When we have just a generic triangle, let's take from angle A. We label angles with capital letters, right? A, B, and C. We label angles with capital letters. Typically, we label sides with lowercase letters. Now, what do we notice about the letter pairings? Is there any pattern? Yeah, we've got angle A is across from side A. Angle B is across from side B. Angle C is across from side C. Remember how we looked at, it was a few chapters back, we looked at the larger the angle, the longer the side is going to be, right? If we have a really wide angle here, then this side is going to be pretty long, right? Because it's a larger angle. If we have a shorter angle, then we will have a shorter side. So it's important to keep in mind when we're looking at the lesson today with the law of sines, our angle pairings. That angle C is across from side C, because that's going to be how we are solving different things later on. Questions about that? Okay. Now, before we get to the law of sines, our main thing for today, we are going to learn how to find the area of a triangle. Now, in the past, when you have found area of a triangle, what have they always given you? So that's how we find it, right? Area equals 1/2 base times height, and they've always giving you the height, right? But now, since we know our trig ratios, we're going to be able to find the area of a triangle when they don't even give us the height, which is pretty wild. If you would have been in your 6th grade mind when you learned area of a triangle with the height, and I would have told you that you can do this without having the height, you would not have believed me. But look, we can. So, the area of any triangle is given by 1/2 the product of, like we can see here, 1/2 the product of the lengths of the two sides times the sine of their included angle. Look, that word comes back again, included angle. We talked about that way back, was it even last trimester? Yeah. For triangle ABC, there are 3 ways to calculate the area, because we could go from the perspective of angle A and use the 2 included sides, like it has here, perspective of angle B with the included sides, or C with the included sides. So we can find the area of pretty much any triangle now. So example 1. Find the area of the triangle. Run your answer to the nearest 10th. Let's see. We're going from angle A. So first, where did our formula go? Area equals 1/2 the two sides times the sine of the angle. So the area of this triangle equals 1/2 19 times 17 times the sine of 135. Now this is all just button pushing, right? We can type this whole thing in our calculator. 0.5 times 19 times 17 times sine of 135. And this would be units squared. What questions do you guys have? In this case, they gave us the angle, and they already gave us the two included sides. So there's no big deal there. But once in a while, they may do something where you have to solve for one of those included sides, or use a different angle. So, go ahead. Find the area of the triangles. You're going to have to draw a picture first. Yeah. I can. Yeah. I guess I did not post the slides, did I? Here, I'll draw the picture for you for number 4 first, and then I'll get them posted. So angle B is 60. Side A, which is across from angle A, is 19. Side C, which is across from angle C, is 14. I actually thought I did post the slides, but maybe not. Is today not published, or just the slides aren't there? Okay. Okay. All right. Should be all set now. And yes, I will need to see these problems before getting the worksheet. Angle C area equals 1/2 . Really? What'd you get for the first one? 115.1813.5672. Wait, how'd you get 2 points? Ah, man. What? Oh, we got to round to the nearest tenth. What? All 10. Thank you for that, Jack. We missed out on Carl's puns today, so. Somebody from the row directly in front of me, what did we get for the second one? Here would be our setup. And then there would be our answer. Good? Questions on either of those? Again, I will need to see that you just wrote the setup and wrote the answer. Well, and drew a picture. It's pretty tough to solve these without drawing a picture. You really don't have to, but considering how our previous quiz went, I think all of us should probably be going a mile above, you know. I'm saying that I asked for questions, no one asked questions, and we get on the quiz, and all of a sudden, everyone has questions. Not everyone. A lot of people have questions. It's amazing. All right. Now, here's the main thing for today. That area stuff I don't think was too bad, right? We look at our formula, take our angle, take the two inclusive sides. We've gotten used to that vocabulary. We're pretty good at just plugging stuff in. Now, the law of sines, this is a game changer, because what do you notice about the triangle on the right that's different from most of the triangles we've worked with in this unit? It's not a right triangle, right? So the law of sines allows us to find really anything. We can find any angle, any side, or whatever in any type of triangle. I didn't hear the rest of that, but no, we cannot find anything with gravity. So here's the law of sines, and it has to do with proportions, right? We talked about proportions right before the quiz, well, the previous quiz, where the sine of angle A over side A is equal to the sine of angle B, which remember will just be some number, over the side of B, and is also equal to the sine of angle C over the side of C. Now, notice that we could write it in either direction, right? We could put the sides on top and angles on bottom, or here. Most of the time, I will probably write it in this way, but there's not anything incorrect about either one. Here's how we would apply that theorem. And you should see that on your page, right? If you've still got your note packet with you, that's on 9.7, which I don't remember if that's the back side of the packet or if it's the inside page of the packet. But 9.7, that theorem will be right there. So, solve the triangle. Round the decimal to the nearest tenth. How are we even going to start setting this up? What do we think? If we need to solve this triangle, how are we going to start setting it up? All right. We know we need the sine of some angle. Yeah, the sine of 115 over 20. Let's say we're solving for C first. The sine of 115 over 20 equals, now what other side do we have? What other side do we have?
11.
We have 11. Is that going to help us at some point? I'm sorry, I don't want to solve for C first. We can't do that because we don't have angle C. We have to solve for angle B first because we have this opposite side. Now we have a proportion set up. That's my fault. We got to take all. We can't solve for side C first because we don't have angle C over here. We got to take the information they give us and see what we can solve for. In this case, they give us two sides and they give us an angle. So we have our angle over the corresponding side equals, again, our side over an angle we're going to solve for. We need to solve the entire triangle, so it doesn't matter what order we go in. Now, how are we going to solve this? What have we been doing to solve? Yeah, cross multiply. Now, 11 times the sine of 115, we can plug in our calculator. Now I need to divide by 20. I'm going to go over here. Now how am I going to finish and find B? What do I need to do? Yeah, sine inverse. Good. Second sine. And we would find that angle B equals 29.9 degrees. Now let's keep solving. Don't worry, we'll do a couple examples before I let you go on the homework. If we, again, are solving for this triangle, we also now can find angle C, right? Because we have 2 out of the 3 angles. So 180 minus 115 minus 29.9 gives me 35.1. And now we have to solve for angle C. Again, we have to use the law of sines because it's not a right triangle. Right? If it were a right triangle, then we could use our sine, cosine, or tangent. Since it's not a right triangle, we have to use the law of sines. So we can use, well, we're looking for side C, so we know that's going to be in the denominator of one of our fractions. Now, what's going to be in the parentheses? Sine of what over sine C? What angle do we need to use if we're solving for side C? What, Rylan? 35. Yeah, 35.1. We have to use that opposite angle. Good. Now, we can set up whatever proportion we want to over here. Sine of one of our angles over the opposite side. I would use, like I've said over and over, the stuff that they had already given us in case we messed up on the last step. So we would have sine of 115 over 20. So we cross multiply. Times the sine 35.1 Now, do I have to take the inverse sine here? Right here to solve this. 11.5 equals C sine of 115. Do I need to take the inverse sine? Yeah. Why not, Ethan? Yeah, because we have the sine, right? Sine of 115 is just a number. So we will divide each side by sine of 115. Because just like pi or any other symbol that is just a number, that's what we have here. So C would equal 11.5 divided by the sine of 115. 12.7. How are we feeling?
Pretty easy.
Really? Yeah. I don't think it's too crazy. Let's look at one more example.
But then we'll get the homework.
It's kind of how it goes sometimes, isn't it? So you've got two practice problems. As you can see, I'm going to go through one of them here. Notice when we're going to learn the law of cosines tomorrow, which allows us to solve for different things in triangles, just like the law of sines does. But notice when we use the law of sines, it's because we have one angle and two sides. That's how we know to use the law of sines. What do you think is going to be the giveaway to use the law of cosines tomorrow? With what information are we going to start with, if we had to guess?
Oh, isn't that adjacent?
Well, not even, that's a good thought, but I'm not even talking about where these sides are located. Just the fact we have one angle and two sides, so we know to use the law of sines. Right, tomorrow they'll give us two angles, one side, and then we'll have to solve for the rest. So just a little preview, something to pay attention to. Now, we know starting out we have to use the given information first. Otherwise, we're not going to be able to solve anything. So we have sine of 51 over our opposite side, which is 18, equals 17 sine of what? What angle can we solve for? C. So we cross multiply. (17) times the sine of 51 and we need to divide each side by 18. Now we just divide each side by sine, right? Divide each side by sine? No, we can't do that. We're solving for the angle, so we need to use what? Sine inverse. We would get that angle C is 47.2. Again, this is one of your practice problems I'll need to see later, so you can either write everything down now or do it on your own in about 2 minutes. Now, where it makes sense to go next, to find next, what can we easily find? Yeah. 180 minus, oh, I should type this in too. 180 minus 51 minus this other angle we just found, 47.2 is 81.8. Now, what's the last thing that we need to find? Yeah, keep going. Whoa, we found it. We found side angle B.
Oh, sine 81.8 over B equals.
Whoa, over little b. Okay. Equals what? What are we going to use?
Oh, 51 and 18.
Yeah, sine of 51 over 18. Now we could use here sine of 47.2 over 17, right? But again, we would rather use the given, just in case. So we cross multiply. And now we can solve. We have 18 times the sine of 81.8. That gives me 17.8 divided by the sine of 51. And that gave me 22.9. How do we know that it makes sense that AC is our largest side? How do we know that that fits with this triangle? We don't have a hypotenuse. It's what? Yeah, because B is the largest angle. So that would make sense that the opposite side is the largest side.
What's that one? I can't see it.
It is 20. Well, weren't you typing it in your calculator with me?
Yeah.
Oh, really? So what'd you get?
22.4.
Close. 22.9. Which you'd see on your calculator if you're typing it with me. Right, Jack? Yeah. That's right. That was still kind of an example problem. Kind of. Example we were doing together. 22.9. Right, Alton? Because you were typing that in your calculator with me. Uh-huh. All right. We just did number 6. I still would like to see it on your paper to make sure that we were doing that example together. But it's up to you to do number 7. And that is for tomorrow. See, look, there's our law of cosine that we're going to use. They give us 2 angles and they give us one side. We talked about that already. We probably could almost do the law of cosine today. Almost. Not quite. According to Big Ideas, we're supposed to do both of them in one day. But Mrs. Lenz is smarter than Big Ideas, so she said, nope, do them in 2 days. So that's what we're doing. Sorry, YouTube, don't block me for that.